Hey guys, welcome to day 8 of Codeforces every day until GM. Today we have this contest round 1072 Division 3. Starts up in 2 minutes. Just gonna try to do as many problems as I can, same as last contest. As y'all know, last contest did not go as expected. It was like pretty difficult for my skill level. Hopefully I can do a lot better. They said this contest should have like 6 to 7 questions, and we're just gonna try our best to do as many as we can. I did a few easy practice problems before just to warm up a little bit this morning. I think 1,000 rated is like the highest one I did. Let's just commit this. And solves get push, and then clear the terminal. Alright, 58 seconds. Whenever y'all are watching this, hope y'all are having a great day. Let me know in the comments how y'all have been, what y'all have been working on, if y'all are doing Codeforces as well, and how y'all have been enjoying the videos in general. I know my videos get like a mixed amount of views, like anywhere from like 2 views per video to like 40, so I appreciate everyone who's watching. It doesn't really matter if no one's watching either. It's just to keep me accountable, I can look back in like 2 years when I'm still not GM and say, hey, I did Codeforces every day. So, yeah. 5 seconds. Let's get it. Should probably create a new file. Just get ready. Bring me into the contest. Let's go. Okay. 2184A social experiment. Okay, let's get started. Largest social N people required to form teams of 2 to 3 people, after which teams choose 1 or 2 civilizations. Organizations social want to know the possible difference in the number of people in the civilizations. Find the minimum possible difference. Okay. Several test cases. First line, single int, number of test cases. Okay. Int input. In the only line of each test case, number of people participating. Okay. The minimum possible difference in the... Okay, so the minimum possible difference will always be under 3 because it's 2 to 3 people, right? We basically just check the minimum possible difference. Okay, let's read. In the first test case, only 1 team can be formed. Right, they choose 2, so they'll have no one. So the answer is 2. Oh yeah, they'll group of 2 and then go to 1. So the difference is 2. Second test case, 2 teams can be formed. One with 2 people, the other with 3. These teams choose different civilizations. So the answer will be 1. Okay, in the third case, 4 teams, the first 2 choosing the first, the remaining 2 choose the second. 4 teams of 3. Okay. Okay. So how do we do this? Well, you want to maximize or you want to choose the same number for each group whenever you can, right? So this sounds greedy to me. Like if you choose 3 for group 1, you have to try your best to choose 3 for group 2, and then at the end it just comes down to whether you choose, I guess 3 and 0, but to minimize, yeah, whether you choose 3 and 0, 2 and 0, or 3 and 2, or if it's even, like 3 and 3 and 2 and 2. Although, what's making this a little bit difficult in my head is, if you do greedily choose, what happens if you come out with like a pairing where if like the second to last one you didn't greedily choose, you did like, because they're both even, right? If one kills 6 people, one kills 2 people. Um, okay, so let's loop through 4 underscore in range t. What's the pattern here? Do we greedily choose 2 or do we greedily choose 3? That's what I'm trying to figure out. If we choose 2, okay, choosing 2 works for all of these cases, low-key. Choosing 2 would always, we're choosing to always minimize over choosing 3 because, okay, what are our end cases? We end up with 4 people left where you can choose, okay, no, let's see. 6 people left, 3, 3. 5 people left, 3, 2. 4 people left, 2, 2. 3 people left, 3, 0. 2 people left, 2, 0. And then if we do 1 people left, we can't do 1 people left. We have to choose like an earlier iteration. We have to choose, like, for example, 3, 2 or something. Like, the number of people is greater than 2. So if we do a 7-person civilization, we did 3, 3. We have 1 person left, so that wouldn't work. We would have to do like 2, 2. Or we would have to do like 3, 2, and then 2, 0. So we can't always greedily choose, so it won't always work. Right? Or if it is it just if you end up with 1, you move to the next? Is it so? Is it okay? We have to take in an input n equals int input, and then if n remainder equals n mod 6 if remainder equals 0. So, okay, this is greedy, right? If we're basically just saying what the remainder is after we try to force this on everyone. If the remainder is 0, then min is 0. If the remainder is 1, then something is wrong. Well, if the remainder is 1, then we know we've done a 5-3, right? If the remainder is 1, so what's a case where mod 6 is 1? 7, right? 7 mod 6 is 1, so we would have to break it up into this case. Well, this wouldn't look like this either. This would be 3, 2, and then 0, 2, so it's 4 minus 3 is equal to 1. So either way, it's 1. So this is interesting, right? If remainder is 1, it's just 1 by default. If remainder is 2, six mod 2, then it's 2. If remainder is 3, minimum is 3. And if it's 4, it's 0. There's something sus about this. Just because of this chain of like remainder checks. But let's just see if it works or not. Just testing theory. Min. Set min to 0. Min. We should get 2, 1, and 0. We did 2, 0, and 0. So this one's wrong. 5 mod 6 is case 5. Oh, yes. If remainder 5 is 1. Oops. Okay, this works, but what about higher cases like 7? 7 should have 1. What about higher cases like 8? 8 should have 0. Right, because we can do 2, 2, 2, 2, 2, 2, 2, 2. That's 0. But our thing won't give us 0. It'll give us 2. So what about instead of greedy 6, what if we do greedy 4? Oh, what if greedy 5 would do 1 of each? No, no, no. We definitely want a greedy one that gives 0. Right. So let's check. If it's 1, remainder's 1, 2, 3. So 8 would pass. 7, what would 7 do? 7 mod 4 is a 3 remainder, so it would be here. But that's not right, because 7 is a 1 remainder. We can do this. We proved already 7 can do this. So what about greedy 5? 5, 6. So, okay, so would it be 3? We need 3, 3, 2, and 2? Because we need 2 instances of 3, 2 instances of 2 to cover every case. It's 36. No, that can't be right. About just 332? What the? 9, 18? That can't be right either. Uh, hmm. Like, what can we do? 2, 3? like, so we have in people. People must split up into groups of 2 and 3, then assigned to Team A or Team B, or Civilization A or Civilization B. So our goal is to minimize size, minimize A and B. So that's our goal. And what do we observe? Any even, right? Any uh so any okay, here's the thing. We can make any integer out of combinations of 2 and 3 except for 1. So what so I think the only special case we would need is like if 1. Else we can like if remainder 1, else we can just build it out of the other integers somehow. The question is it's probably not remainder. It's um let me think. Mm, okay, can we brute force this somehow? I don't think we can just straight up do math on it. Like we're gonna have to do a loop for n plus 1 would be the length of the array, or the n plus 1. No, n would be the number of people plus 1. So, say we're taking in an input of 7 people. Right? Say we take in. Can we just try? 0. Like, okay, we have civilization A, civilization B. Say we have 7 people. Okay, or if civilization A would be 1, 0 equals 1. 2 would be 2, 0 equals 2. 3 to minimize, it would be 30. Wait. Yeah. 4 would be oh no, I'm thinking about this all wrong. What if we had 1 and 6? So what if we just 1, 2, 3, 4, 5, 6, 6, 7, and then B was 7 minus A, which is 6, 5, 4, 3, 2, 1, 0. And then we can form all of these except this one because A has a 1 or I guess we can form all of these, right? Because these have 1, so and we can form this one technically. So then we just iterate through this, the ones we can form, and see how good they are. Right. Okay, since we can form all of these, we we don't actually have to like split them into teams. We can just like check these numbers and see if they work, I think. So for I in range in A is equal to I, and then B is equal to I minus 1, or I minus n minus I, and then if A is not equal to 1 and B is not equal to 1, then we can run this formula, right? Abs A minus B. It should be something along these lines. So we should track an answer, right? Set and set minimum to just the largest number possible, which would be n. And then we take the minimum of it and abs. So it's n equals minimum abs or no m. Why did I call it min? M m m m is the minimum of abs A minus B, and then This would go from 0 to n. So let's test this. Wait, what happened? 3, 2, 5. So, oh yeah, I don't print anything, right? I would print right here. Print m. So 2, 1, 0. 0, 1, 2. Okay. Does this work? Alright, we should test 7. 7's 1. Okay. What other sus ones were there that we can test? Because we lose 10 minutes for each unsuccessful one, right? Uh, so like, uh, wait. What about like case 1 or something? Case 1 is impossible, right? Yeah. This should work. Please speed. This question took me 33 minutes. I'm stuck in queue. Hello? How do I go to the next question? I've never been in queue for this long before. Hello? Okay, we can look at B while this is in queue for 5 years. Is this working correctly? Never seen that before. Hey, B. What is this? 2184 B. Hourglass. Pi. Okay, it's weird. Okay, my hourglass measures S minutes. Flipped it over, and the time started every K minutes. We'll flip again. He'll do this even if sand's still falling. Also, if the sand has already finished falling, but there's still some minutes left, He'll wait for the required time and then flip. Each flip is done instantly, however, needs to leave for around in minutes, so he'll stop flipping. If he needs to flip in the last minute, he'll do so. Determine how many minutes the sand will continue to fall after the hourglass leaves. So, test cases. Oh, this is crazy. Why am I in queue for 5 years? I'll message your buddy about this. I don't know, because last time um, they did it instantly, so for each test case, I'll put how many minutes the sand will continue to fall after it leaves. Okay, it seems like it's supposed to be normal. Or I guess it's just busy. That's what my friend said. But okay, we keep working. Stop flipping the hourglass. In a single line of each test case, there are 3 integers. Number of minutes the hourglass measures, number of minutes hourglass flips. So SK and M for in range T, we're given SK M equals input or map input or map int input. How am I messing this up still? Like dot split. I've done this so many times. I should just be good at this now. Each test consists of several test cases. The first line contains a single int t. The number of test cases following describes the test cases. 3 integers, minutes after which the hourglass flips, and the number of minutes after. Okay, so this is our max time. How many? Average. Okay, so every k minutes. So this is k. Begin. So basically, this would be. You flip it at 8. So it would be empty. He flips it, and then it runs for 4 more minutes. This one, it'd be empty at 10. He flips, and then it's empty at 15 minutes. And so at 17, okay. So basically, if what's a case if the time it measures Um, so if this minus this, or wait, no, this has 7 minutes. Two. If this minus this is less than this, is greater than this, it's 0. Wait, if this minus this is 7. If so, if abs this minus this is greater than this, it's 0. Does that hold true? So if it was like 17 and 10. Yeah. Okay, so here's a case if m minus k, so if s is greater than or equal to m minus k, let's get some more room. If s is greater than or equal to m minus k abs, we get 0. If not, TLE. Okay, we'll go back to the previous question. Hmm. I don't really know. Can we do this? Like, this is O to the n, right? Because, like, this is t. Does it want us to do it even faster? Like, how can we reduce the constraints? Or can we do it with remainders? Like, O to the 1? Because with remainders is just O to the 1, right? I don't understand. I guess the answer is it's just math. Hmm. So if it's even, if it's okay. So what cases do we have? We're back to here. If it's 1, it's bad, but it'll never be 1. If it's 2, it's 2. If it's 3, it's 3. So if n equals 2, print 2. Elif n equals 3, print 3. Elif n mod 2 equals 0. So if it's even, minimum is always 0. Elif else it's 1. Right? 2, 1, 0. Let's test the strange cases. When it's 1, it goes on. Well, it'll never be 1, so I guess we can try it still. 1, 1, 1. When it's 2, it should be 2. When it's 3, it should be 3. When it's 7, it should be 1. When it's 8, it should be 0. When it's 9, it should be 1. Okay. I mean, this should work, right? Did we have any other cases we were stuck on? Okay. Why is this red? That's not good. I can close this, I think. It's going to be in queue for 50 million minutes, and back to working on this problem. So if S is less than or equal to abs in minus k, print 0. And then we're given SKM. So I'll put the minutes and we'll continue to fall after he leaves. So, okay, let's say we have, like, we flipped it, and then it's an 8-minute total hourglass. We flipped it, and then the time runs out when it's 6. Would the answer be when there's 6 minutes still remaining in the hourglass? Would the answer just be 6? So still in queue. Okay. So what? Remaining sand. So after we flip there's the number of minutes. K is last time we flipped. S minus K. We have this. So if K is greater than or equal to S, flipping doesn't matter really. Because the S would just run out. Then we flip it and it just run out. And then, okay, let's write this down. If K is greater than or equal to S, flipping doesn't matter. If K is less than S, then oh cool, we got it. If K is less than S, then what happens if K is less than S? K is the flip time. If K is less than S, then we like gain time in the hourglass. Or no, we don't. We is it called gaining time? It's like the sand remaining is. What does the sand remaining become? It like depends on the flip. Right, so does it? So how does it depend on how many flips we do? Or what? Uh okay, so how many flips can we do in a session of M? That's modulus. So M mod K flips. Well, okay. M mod K. Right, and what do we do here? So how does the number of flips affect our sand level? It doesn't matter if k is greater than or equal to s. So sand sand can never exceed s. Hmm. 8. So 12 mod 8 is 4. Wait, it's not, mod is not the, it's assuming the hourglass was full at the last flip. Oh, it gives us the number of flips. Dividing gives us the number of flips. The modulus gives us the number of time left after the last flip. So it's saying it has 4 left. And then what? We have 8. We start at 8. We flip once. Our thing runs out. We flip it at 8 minutes. Let it run for 4, and there's 4 left. Okay, what about the second case? We start at 5. Oh, this is case where 5 is less than, where k is greater than or equal to s. So this one's just 0. Right. Or I have to refine it a bit. But it would work with our earlier formula, this one. How many flips would we do? We would do 1 flip with a remainder of 7 minutes. And then we would run now before. So it's 0, yeah. For this one, we would do 1 flip with a remainder of 1. Or, yeah. So 12 runs for 2 minutes. It's at 10. We flip it. Runs for, so there'd be 1 left in there. So I actually cannot visualize this problem. So, okay, all I know is we have this num flips is equal to m mod k, or flips remainder. Flips is equal to m double divide k. So, flips is m double divide k. Our remainder is equal to m mod k. Now, what can we do with this information? We should track a time variable, and then sand remaining variable. Sand remaining should equal to s, and then for while time is less than m. I guess we can just try a brute force approach, see if it works or not. While time is less than m, uh, time past time how do we increment time here? It's just okay, m was the total number of minutes. K is the minutes per flip. Okay, do we even loop through this? How can we calculate the amount of sand given the minute? Sand remaining, it starts at S. So it starts at S, then it goes until flipped. Um, when it's flipped, so after K minutes, it's S minus K, which is flipped, so it's K minus S. Right, okay. We can do it like this. S K S minus K. This is too small. S K S minus K is K minus S. Flip it. K minus S, S minus K. So then, after another K, we get K minus S minus K, S minus K, S plus K, K, S minus K. And this is just K's number of minutes. This is just K. And this becomes K. S minus K. And then we'd get K minus K over S, because you would do plus K. So it's 0 again. 0 over S, which when flipped, it's S over 0. Oh, wait, this is a good pattern to have. So it's even, it's filled again. This is 0, 1, 2. So it's even, it's always S minutes left. If it's odd, it's S minus K left. If even, flip. If odd, flip. S. Wait. So at 1 minute, or at an if at an odd, the first flip, there will be K left. If even, flip, there is S left. Or this actually simplifies it so much, right? So then we just need to check the last case. M minus what? M minus K. If it's, oh, why can't I see shit? If it's even, wait, if odd, then just M minus K. If even, S minus K. Wait, M minus S? That ain't right. it'd be K. What the? K minus M, and then S minus M. That sounds more like it. If it's negative, then 0. How does this hold up? It's so this divided by this is odd. So K minus M, 8 minus 12 is 4. Yeah. This is odd. Then it's 7. Wait, S minus M. Wait, it's odd, so K minus M. K minus M is negative, so it's 0. This one, uh, it's 1, so odd. Odd means K minus M. 2 minus 3 is negative, so it's 0. That ain't right. Because this is greater. K minus M is 1. Or is negative 1. Well, we need to do something with S. K is S is 8. K minus M is 4. Is negative 1. Or is negative. But this is supposed to be S, or this K minus M is negative 7. Still negative. Negative 1. There's one flip. We flip this once, so this becomes 12. It starts at 12. After 2, it's 10. But we flip it, so it's 2. Right? 2 minus M Where's k minus m? -1. K minus m is 3. So instead of m, should it be m mod k? Let's see. 4. M mod k is 4. 8 minus 4 is 4. M mod k is 7. S and M mod k is 7. Odd, so k minus 7 is 3. It's not right. How much time do I have? 53 minutes? But this case, so it's 0. Well, I guess k is this wouldn't be k, this would be max min. K and S, right? If it's odd, one flip, yes. So it'd be 5 minus 7, which is negative, so 0. 3, so flips is 1. Which is odd, so the minimum of S and K is 2 minus M mod K, which is 1. 2 minus 1 is 1. Okay, that seemed to work. We haven't tested an even though, like when even flips. So like, what is an even flip? When M is 4, K is 2, it's even, and let's say S is like 5. We have 5, M is, or K is 2, M is 4. Then it would be even is S minus M mod K is 0 equals 5 minutes left? Is that right? 5. First flip, it'd be 2. Run for 2, 5, then 2. Well, it'd be 0, right? Because it'd be 5, 3 left, 2, flips. First flip, second flip, after 2 would be 0, 5. That's 2 minutes, 4 minutes. What about after 5 minutes? 5. And then this should be 5 minus m mod k, which is 1, equals 4. But if it was 4 minutes, it'd be 5 minutes. Yeah, I think this is right, actually. Wow, that took me a little while to derive, so. Flips. If flips mod 2 equals 0, print s minus m mod k, else print min sk minus m mod k. Negative 13, that ain't right. 4, negative 2, that ain't right either. Oh, we track a 2 print. Now let's check if all these other ones. If negative, just set it to 0, right? So it's 1, 7, 1, 0. Okay. 2 print equals if 2 print is less than 0, print 0, else print 2 print. Four zero one 710. 401,710. Okay. Hourglass. Okay. We just have to hope it's right. Contests. Oh, it's running. Enter. Huge pile. Oh, yes. That's great. We needed that. Alright, I need a P. But I'll just create the file for this. 2184C. Huge pile dot py. Control C. And then rating question mark. Alright, I'm gonna pee. I'll be right back. We're doing great. Alright, I'm back. Let's keep going. Andre has a pile of apples. Divide into two smaller piles. You'll get piles with star and cross. What does that mean? Andre wants to eat K apples but doesn't want to count them all. That's why he wants to obtain a pile with exactly K apples. Determine whether it's possible to achieve this by performing pile divisions. If it's possible, find the minimum possible time to obtain a pile. Okay, star is the largest integer less than or equal to x divided by 2. And then cross is the smallest integer greater than or equal to, okay? Um, just take this t input thing. And then given two integers, nm, uh, okay. Number of apples in the huge pile and the number of apples you want to obtain. For each test case, output -1 if it's impossible to obtain a pile with exactly k apples. Otherwise, output the minimum possible time to reach such pile. Pile divisions. He will get piles with the floor of x over 2. What does that mean? Okay. In the first test case, two piles of 5 will be created. If one of them is divided, it will result in a pile of 2 and 3 apples. So the answer is 3. So, okay. Second test case, 5, 6. He wants 5, so answer is 1. Third test case, it's only possible to obtain piles with, this would be 10, 11. 5, 5. And then 11 would be 5, 6. You can do 2, 3. And 1, 1. And then 6 would be 2, 3 as well. So we can't get 4. Right. I see. Um, let's think. How can we... What if... brute force. We can always try brute forcing it. But... So we want to perform divisions. where we get x divided by 2 11 divided by 2. And then a given number of apples, output -1 if it's impossible, to obtain a pile with exactly k apples, else output the minimum possible time required to obtain such pile. Okay. N is the number of apples in a pile. K is, so if where's, find some room. Okay, let's just go down here. If k is greater than n, impossible, so -1. If k is equal to n, then 0. Those are the given cases, like base cases, right? Every spit has the piles basically. Has the piles. K is greater than n. This one's supposed to be k, right? If k is greater than n, print -1. If k is equal to n, print 0. Yes. Now what? So we're given n, cut n up into n divided by, okay, we have to check if n is even or odd, right? Do we? If n is even, then we only worry about 5. So if n mod 2 is 0, then it's just n divided by 2. And then we run this again. Else, we go to n can be split into n divided 2 and double divide 2 plus 1. And then we would take these and shove these into this thing. Right? So this is kind of what the code should visualize into. Although these are kind of the same, right? So if n mod 2 is 0, I just realized these wouldn't be break, they'd be continue. Because we're not inside of a loop yet. If n mod 2 is equal to 0, splits equals this. If mod 2 is equal to 0, well, we can set this to a set, because we don't care about duplicates. And then splits dot add n double divided by 2. And then else all plus 1. Okay. Now we need to loop through this. How do we loop through this? We're given. We need to loop through splits. No, we need to loop through. So this is our default case. Wow. Uh. 'Let's see. While K is not in splits. While K not in splits. Or 0 in splits. No, that wouldn't work. Dun dun da dum bum bum bottom bum 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 bottom. Okay, is not in splits. Wait, okay, I'm stuck because like one of these will break into 0 first. Like the left one will break into 0 first. It would be like we have to split like 3 or something, and then divide by 2 is 1 and 2. And then this one, what do you do with 1? You do divide by 2. 1 double divided by 2 is 0, right? Yeah. And then 0 plus 1 is 1. But then you need to move on over here. It's 1, 1. So it's not the first time you encounter 0. It's not the second time you encounter 0. It's not the third time you encounter 0. It's not the fourth time you encounter 0. It's when you go through all the elements. But the thing is, splits is ever changing. It keeps changing every time we implement. It might. So when do we end it? I don't think we can use splits here. Or I don't think we can use a set. Right. Wait, isn't this just a tree? What the? It's a binary tree. Bro, I don't remember how to do this. Last time I worked with a tree was in my data structures and algorithms class. I'm given an integer. So let's not use a set. Let's use an array. How do I build out this tree? Our root node is in. Right? Um, and then it's like this is index 0, index 1, index 2, index 3, index 4, index 5, index 6. Right. So how much time do I have left? I don't think I have enough time to learn how to do binary trees in 20 minutes. But I think this is a solution though. Like, alright, okay. So how do I, because it's like this, it's like, it's gonna look like 0. Let's just give these arbitrary numbers 3. Let's say this is 1, 2, 3, 4, 5, 6, like 2, 3, 6, 7, 10. Let's do like 1, and 4, 5. It'd be like 2, 3, 6, 7, 1, 4, 5. Right? And then it would be. So how do I find the length of this, since I can't just append? I have to break it up, do the left side, append left, append right, go back to left, A pen left. A pen right. Go back to the other right. A pen left. A pen right. Oh my god. Wait. But then how do I know to go to this one? Uh, is it Jover? Chat? Let me do some Googling. Okay. Basic operations. Size of a tree. Recursion. I have to write it iteratively. Alright. We have 17 minutes. I don't think I'm going to be able to learn, like, meaningfully learn, like, a binary tree. Because, like, I get the idea, right? The idea is to loop through and create this tree and then search. Right? I get this is BFS, right? Breadth first search, right? You create all the nodes, and then you look through and see if your node exists. But I don't remember how to do that. It's been like a year since I did BFS in my DSA class, so I am gonna need to review this, and I think I'll just get back to y'all in tomorrow's video. I'll go over this question with my buddy who knows what he's doing. And yeah, we'll call it. We did good today. We did 2 questions. That was an improvement from last contest. But yeah, if y'all enjoyed this video, be sure to like and subscribe. I've been posting more shorts lately. I think I fixed the quality thing, which is good. So go check those out if you're interested. Other than that, have a nice day. Just leave a comment in the comments if you want to say something. I'll talk to all of them. But yeah, other than that, see y'all guys next time.